Question 7. A researcher wishes to compare the effect of two stepping heights, low and high, on heart rate in a step aerobics workout. The researcher constructs a 98% confidence interval for the difference in mean heart rate between those who did the high and those who did the low stepping heights. The researcher decides to test the hypotheses mu1 minus mu2 equals 0 versus mu1 minus mu2 less than 0 at the 5% level and produces a p-value of 0.0475. Which of the following is a correct interpretation of this result? All right, so I'm guessing that it wants us to interpret this result, which is the p-value. So we're probably going to be looking for a statement that interprets the p-value correctly. All right, so choice A, the probability that there is a difference is 0.0475. Okay, no, that's not the correct interpretation of the p-value. Usually when we interpret a p-value, we say something like, if the null hypothesis is true, and then we would write what that is, there is a p-value probability of getting the observed result or more extreme purely by chance. Right, so that's kind of like the generic interpretation. So I would say if the null hypothesis is true, meaning there's no difference between the mean heart rates of the two groups, then there is a 0.0475 probability of getting the observed result or more extreme purely by chance. Okay. Now in this case, more extreme would be like less than, I guess. All right. Anyways, let's keep going. Choice B, the probability that this test resulted in a type 2 error is 0.0475. Okay, so no, that's not right. It's very hard to calculate the probability of a type 2 error. Right? When we did the activity in class, we had to use computer software to do it, so it's not going to be as easy as just, oh, it's the same as the p-value. All right, option C. If this test were repeated many times, we would make a type 1 error 4.75% of the time. Okay, no. The probability of a type 1 error is equal to alpha, which is 0.05. So we would make a type 1 error 5% of the time. All right, D. If the null hypothesis is true, the probability of getting a difference in sample means as far as or farther from 0 as the difference in our sample is 0.0475. Okay, I like that. What about E? If the null hypothesis is false, oh, okay, no, okay, all right, so D is the answer.